All right, guys, so today we are starting Chapter 6, Relationships Inside of Triangles. So again, we're still talking about triangles. We were talking about triangles, well, not immediately before the break, but Chapter 5 was completely about triangles. So Chapter 6 is also going to be about triangles. There's a lot to do with triangles, and triangles are really important. And, well, as I've said already, hopefully I've said already, they've actually found an entire subject based off of triangles. It's called trigonometry, all based off relationships with triangles and how triangles work. Now, for Chapter 6, we're going to cover it this week and next week, and so that it will be probably, most likely as I've got it planned out, Chapter 6 text will be your midterm. So I'm planning on that being your midterm. Now, the first thing we're going to talk about with Chapter 6 and relationships inside of triangles is going to be the perpendicular bisector theorem. So in a plane, if a point lies on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So a lot of words there. But really what it's saying is if, so here, we have a point on the perpendicular bisector of a line. These two here are congruent, so it bisects that line in half, and we have a right angle, so it's a perpendicular bisector. So that point is equidistant from the endpoints. So CA is congruent to CB. Those two would be congruent because I have a perpendicular line, because the two lines are perpendicular, and it cuts them in half. And that's it. That's all it's saying. So let's look at an example here. So here we have a point S, which lies on the perpendicular bisector. Well, I know it's a perpendicular bisector because, one, we do have a right angle here, and it's cut in half. These two segments are congruent. So it is a point S lies on the perpendicular bisector of these two lines here. And because it lies on the perpendicular bisector, it means that these two lines here are going to be congruent. They're going to be the same. So since SP is 6.8, it means that SR is going to be 6.8. And it asks for RS, SR, the same thing, so the measure is 6.8. That's all we have to do for this year. Okay, let's look at the next one. We want to find the measure of CD. CD, so we want to find this measure. Now looking at this here, well, point D lies on this line here, and it's a perpendicular bisector. As well, these two here are the same, so this line cut it in half, and it intersects it at a right angle, so this here, BD, is the perpendicular bisector of AC, so therefore, it means that AD and DC, or AD and CD, are congruent, so the measure of CD is going to be 27 because they are the same. They're going to be the exact same. That's all we have to do for this here. And that's it, because if it lies on the perpendicular bisector, those two are going to be congruent. Now, the converse of the perpendicular bisector theorem, so the opposite of what we just have, in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So if I have a point that's equidistant from two other points, so if these two lines are congruent, it means that these two have to be congruent as well. So let's look at an example. Let's just dive right into an example here. Well, these two here, 24 and 24 are congruent. And since these two are congruent by the converse perpendicular bisector theorem, it means that these two have to be congruent also. Now we're looking at this here. Well, these two are congruent, and I have a perpendicular line through the point off of the other line. So these two here, we have all this set up. It means that these two have to be the same. So EF has to be 9.5. And that's what it was asking for, yes? So EF, well, no, EG. Now, EG is the whole line, E to G. Well, EG is made up of the two parts. It's equal to our EF, which was 9.5, plus FG, which was also 9.5. And all we've got to do is add those together to get the whole length. And if we add those together, we should get 19. That's all we had to do for this here. Let's look at the next problem. Now we point off the line that is equidistant from the two endpoints of another line, and we have a right angle there. So these two here are congruent, and because these two are congruent and we have this set up, it means that these two here, these two other sides, have to be congruent as well. So that means QR and QP both are going to be 5. Well, it didn't ask for QR, it asked for PR, it asked for the whole length. Well, I know the two parts are 5 and 5, and if I want to know the whole, well, we can add those two together, which would give us 10. That's all we have to do for this here. All right, now we don't have to have just equations or just numbers, because so far we've been using this. It's just been, okay, this side is 15, this side has to be 15. We've just been matching numbers up. We haven't actually solved for anything. Now we can use this with equations. Now we look at this problem here. Well, we have two congruent sides. These two are congruent. So it's being cut in half. BD, line BD cuts line segment CA, this segment, into two congruent parts. And we have a right angle, so it's a perpendicular bisector, which means that these other sides here, these two have to be congruent. They have to be the same. Well, that kind of helps us because, again, what we're trying to do is we're trying to find the measure of AD. But all I know for certain is that AD, which is 5x, is equal to our 3x plus, not 13, 14. Because this is all we know for sure so far. We know that these are equal. It doesn't tell us what the measure is, but I know that they're equal. Now this is kind of helpful because if I can set these equal to each other, that means I can solve for the value of x. Once I find the value of x, I can plug it back into one of the sides to find the length I need. Now looking at this here, so we have 5x equals 3x plus 14. And we want to solve this so that we get x by itself and we see what x is equal to. Well, the first thing we need to do is we need to get x on the same side. So I'm going to subtract 3x from both sides. Because here, 3x minus 3x, these are going to cancel. Well, 5x minus 3x leaves us with 2x is equal to 14. Now at this point here, we can divide both sides by 2. We can divide both sides by 2, and when we divide both sides by 2, we get x is equal to 7. So that's good. That's on our first step. So we found out x is equal to 7. Now that doesn't tell us exactly what the length of AD is, but we know what the value of x is. X is 7. Now to find the length of AD, we have to plug it back in. We have to plug it back into our equation for 5x, because AD is equal to, so what we've said is AD is equal to 5x. Well, we found out what the value of x is. X is 7. So we can do 5 times 7. And 5 times 7 is 35. So the value of AD is 35. And we have our answer. And that's all we need to do for this here. Now, if you're wondering, we could have done this using the other length. We could have done it with 3x plus 14. And I could have plugged in 7 into this one here also. Because if we do this here, well, 3 times 7 would give us 21. Plus 14. Well, 21 plus 14 is 35, which is the same value we got for AD, or doing 5 times 7. And they should be the same, because CD and AD are congruent. They're equal, so they should have the same value, which we found out they did. So here the answer for AD, or the value of AD, the length of AD is 35. And that's all we have to do for this here. Now here's another one. Now this one here, again, we have a perpendicular bisector. So these two are congruent and we have a right angle. So it means for us that 2x is equal to our 3x minus 8. And the reason we set these together is because we want to know the value of GH. Well, to find the value of GH, we need to find the value of X. And once we find the value of X, we can plug it back in and solve. Now looking at this here, well, I need X by itself. Now there's different ways we can go about it, but I think the easiest is probably going to be, or the quickest is going to be, to subtract 3x from both sides. Now I don't normally like doing this because it's going to make x negative, and we'll see that here. 3x minus 3x, these will cancel. And what that'll leave us with is our 2x minus 3x, which would be negative x, equals negative 8. And I don't normally like doing this because we have a negative x, but this is fine. It's going to be shorter. It's going to be faster to do it this way. So we've got all the x's on one side, but it's negative. So what we'll do is we'll divide by negative 1. We could have multiplied by negative 1. It would have made no difference. But negative x divided by negative 1 will give us positive x equals, not m. Well, negative 8 divided by negative 1. Well, the negative and negative would make a positive, and 8 divided by 1 will be 8. So we found out the value of x. We set them equal to each other because we said HE and GH are congruent. Those two lines are the same because of our perpendicular bisector theorem. And we found and solved that the value of x is 8. Now what we need to do next is we need to plug it back in. Now, does it matter which one we plug it back in? Well, no, because they are going to be the same. They will have the same value. So we could do 3 times 8 minus 8. Well, 3 times 8 would give us 24. And 24 minus 8 is 16. Now, if we did the other length, 2 times 8, well, 2 times 8 is 16. And we see that we get the same value. So the length of GH, the value of GH, is 16. And that's all we have to do for this here. So we'll look at a few more of these here. Now this one here is ZX is a perpendicular bisector of WY. And YZ is 13.75. 13.75 right there. Find YZ. Well, because of our perpendicular bisector theorem, it tells me what? It tells me that these two segments are the same. WZ and YZ are congruent. So since they're congruent, it means that WZ is 13.75 because they're the same. And that's all we have to do for this here. Since one side is congruent to the other, one of them's 13.75, the other has to be as well. Now this one here, so XZ is the perpendicular bisector WY. WZ is 4n minus. And then it says, and YZ, the other side, is n plus 17. And that's the other length. So our two lengths, one of them's 4n minus 13, the other's n plus 17. And we know because of the perpendicular bisector theorem, these two lengths are going to be the same. They're going to be equal to each other. So we'll set them equal to each other. We'll have 4n minus 13 is equal to n plus 17. We take those two side lengths and set them equal to each other because we know that those two lengths are congruent. They have the same value, so they must be equal. Now, the reason we're doing this is we want to find the value of n. And once we plug it back into YZ or WZ, we can find the length that we want. And for this one here, we want to find the length of YZ. So when we look at this here, we set it equal. So 4n minus 13 is equal to n plus 17. And let's solve for the value of n. So the first thing I'm going to do is get n on the same side. So I'm going to subtract n from both sides. When I subtract n from both sides, well, 4n minus n gives me 3n minus 13 equals, well, n minus n will cancel, leaving us with just 17. These here will cancel. Now what we need to do next is we need to get n by itself. So here, what we're going to do is we're going to add 13 to both sides. Add 13. And when I add 13 to both sides, on the left side I will have 3n, and it will be by itself. There's nothing else added or subtracted because our negative 13 plus 13 will cancel. Now 17 plus 13, if we add those together, we will get 30. Now we're almost done. We're almost done with solving for the value of n. Now the last thing we need to do is we need to divide both sides by 3, because when we divide both sides by 3, well, 3n divided by 3 will give me n equals, well, 30 divided by 3 would be 10. So the value of n in this case is 10. Now we want to find the value of yz. So for this here, yz is n plus 17. So we'll plug in 10 for n. So that'd be 10 plus 17. And 10 plus 17 will equal 27. So the length of yz is 27. And that's all we have to do for this here. Use the diagram of the given information to find the indicated measure, not indirect, indicated. Find wx. So we want to find this length. Now we're told that wz is 20.5. Well, there we go. They're all plugged in. So yw, not yw, yz is 20.5. Yw, the bottom length, the entire bottom length is 14.8. And we're told that yz is 20.5. Now, because of our converse perpendicular bisector theorem, because yz and zw are both 20.5, it means that these two segments down here are going to be congruent. Yx and xw are congruent. Well, if they're congruent, it means that whole segment is really cut in half. It's bisected. It cut it in half because those two segments are congruent. They're the same. So what we can do is we can take 14.8. We can take this value here. We can take this 14.8. I moved it over here. And what can we do? We can cut it in half. We can cut it in half. And if we cut it in half, or really what are we doing? We're dividing this by 2, because it's cut into 2 equal parts. What we're going to get is 7.4. And the value of the segment that we're looking for, wx, is half of the length of wy, which would be 7.4. And that's all we have to do for this here. That's all we're looking for. Now we have these last two theorems. This is one of them. The other is going to be the converse of it. And this first theorem here is the angle bisector theorem. If a point lies on the bisector of an angle, then it is equidistant from the two sides of said angle. So point D lies on the perpendicular bisector. We know that because these two angles here are congruent. So it means the distance from here to here is going to be the same as the distance from here to here. And it also works out that it makes two right angles. So when we look at this here, BD bisects ABC. So this is the perpendicular bisector. It means these two angles are congruent. Then it tells us that DC is 6.9. DC is 6.9. And we want to find the value of DA. Well, if DC is 6.9, because of our angle bisector theorem, it means that DC and DA are congruent. They're going to have the same value. So the length of DA is 6.9 because they are congruent. They are the same. And that's it. Now the same thing is true here because JKL is bisected by ray KM. We have an angle bisector. It means that these two here are going to be congruent. They're going to be the same. So what it's telling us is that 4x is equal to 2x plus 12. Well, why are we doing this? Because we want to find the length of JM. JM this here. Well, to find the length of JM, I need to know the value of x. To be able to find the value of x, well, I know that these two lengths are congruent, so I set them equal to each other in order to find the value of x. Well, the first thing we can do in finding the value of x, well, that would be to get x on the same side of this equation. So I would subtract 2x from both sides. Well, 2x minus 2x, these will cancel. And what I'm left with is, well, 4x minus 2x would be 2x is equal to 12. Now the next thing we need to do, because x is not completely by itself, we need to divide both sides by 2. And when I divide both sides by 2, well, 2x divided by 2 would be me x is equal to, well, 12 divided by 2 is 6. So I found the value of x. Now all I need to do is plug it back in, and once I plug it back in, we will have the value of x. And so for this here, we're just going to do 4 times x. Well, x is 6. So we'll type it in as 4 times 6, and 4 times 6 is not 21, but 24. So the length of JM, the length of what we're trying to find, is 24. And that's all we need to do for this here. And we're done with this problem. Now this problem is exactly like the last one. So we have an angle bisector. I know that because the angle's cut in half, that these two here are congruent. So it means that these two line segments here have to be congruent as well. And so what we can do, we can set it equal to each other. We can set 5x equal to 6x minus 5. And what we want to do is we want to get the value of x by itself, because once we get the value of x by itself, we can plug it back in and find our length. Now the first thing we can do is we can subtract 6x from both sides to get x by itself. Well, 6x minus 6x is going to cancel. And we have 5x minus 6x. Well, 5x minus 6x will give us negative x is equal to negative 5. Now we're almost done. We almost have x by itself. But right now we have negative x, and I don't want to know the value of negative x. I just want to know the value of x. So I'll do negative x divided by negative 1, which will give me x is equal to, well, negative 5 divided by negative 1 would be 5. And now we have the value of x. Now all we need to do is plug it back in. Now it really doesn't matter which one we plug it back into. I'm going to use the 5x because that's a little bit easier to work with. And when we plug 5 back into 5x, 5 into the value of x, well, 5 times 5 would give us 25. So the length of PS is 25, which means the length of RS is also going to be 25. So 25 is our answer for this one here. Now we can do this also. We can use equations just like what we did. We just did this in the last one, so we'll do it here again. BD bisects angle ABC. AD is 3z plus 7, and CD is 2z plus 11. Find the length of CD. Well, because I know it's an angle bisector, I know that AD and CD are going to be congruent. And since I know they're congruent, I'll set them equal to each other. And the reason we're doing this is to find the value of z. And once I find the value of z, I can plug it back in to find the length of CD. So we set them equal to each other. Now the next thing we can do is get the value or z by itself. So I'm going to subtract 2z to get z on the same side of the equal sign. And 2z minus 2z here will cancel. So that'll leave us on the left-hand side. The 3z minus 2z would be z plus 7 is equal to, well, the 2z's canceled. So I'm left with 11. Now z is almost by itself, but I need to move the 7, so I would subtract 7 from both sides. And when we subtract 7 from both sides, we're left with z is equal to 4. So we found the value of z. Now all we need to do, all that's left, is to plug it back in. So when we plug this back in, we're going to plug it in for z, so I'm just going to pick one of the equations. So I'll pick the 2z plus 11, so we would do 2 times, well, our value of z was 4, plus 11. Well, 2 times 4 is 8, and 8 plus 11 gives me 19. So the length, the value that we're looking for, the length of CD, the measure of CD is 19. And that's all we needed to do here. That's all we needed to do to solve this one here. Now the converse of the angle bisector theorem is if a point is on the interior of an angle and is equal distance from the two sides of the angle, then it lies on the perpendicular bisector of the angle. So if we have a point on a line that's equal distance from the two sides, it means it's a perpendicular bisector, or an angle bisector, not perpendicular. An angle bisector is going to cut the angle in half. So we look at this here. Point J is equidistant from the two sides. These two are congruent. So it means it's an angle bisector. These two angles have to be the same. So the measure of GFJ is going to be the same as JFH. This angle here is going to be 42 degrees because it cut it in half. It cut it into two congruent parts. Now, if I wanted to say I wanted to find the measure of, now say I wanted to find the measure of GFH. Well, GFH would be the whole angle, so I would just need to add 42 and 42 together. Together. To get that whole angle would be 84. So if we wanted the whole angle, we could add them together to get 84. And that's all we have to do for this here. Now this one here would be similar because again we have a point inside the angle that is equidistant from the two sides. These two are equal. So it means it's an angle bisector. So these two angles here are cut in half. So the measure of ABD would be 56 because it cut it in half. Well, that's not what it asked for. It asked for the measure of ABC, the whole angle. Well, that's not too hard to get because if I want to find the whole angle, well, I just need to add the two parts together. And our two parts are going to be 56 plus 56. And if we add those two together, 56 plus 56, we can do that in a calculator. It would be 112 degrees. And that's all we'd have to do to find the value of that angle, that big angle that it wanted. And we could do this one here. I'll let you do this one here on your own. Give it a try, see if you can figure out what it is. And hopefully, once you went through and solved this here, well, it tells us that AD is 3.2 and CD is 3.2, which means it's going to be set up like this here, 3.2 and 3.2, since these are the same. It means we have an angle bisector, so both of these would be 39. Now, the angle we're looking for is ABC. So to get that, we would take 39 plus 39 and see that there is 78. So the answer it's looking for this year is 78. And that's all we're going to do for this year. That's all we're covering for 6.1. Your assignment is already up on Big Ideas Math, so go on up there, work on that. And if you have any questions, please email me, let me know.